Welcome to the Deep Dive. We're your shortcut to getting informed, maybe with a few surprising facts thrown in, and hopefully enough interest to keep you listening.
Sounds good.
So today we're diving into something pretty big that happened recently, grabbed headlines everywhere, really.
Right.
A massive earthquake, magnitude 8.8, off Russia's Kamchatka Peninsula. That was July 29th, 2025.
A really significant event.
Exactly. So our mission today is to unpack what happened with the quake itself, then look at the tsunami it kicked off across the Pacific, and then, this is the really fascinating part for me, explore some unexpected geological connections that kind of popped up afterwards. We've got the sources you sent over to guide us.
And it's important to remember, right from the start, this wasn't just, a local Russian event.
No, definitely not.
The second that quake hit, tsunami alerts just shot across the entire Pacific. Think about how fast that concern must have spread.
Instantly global.
Yeah, it's reaching nations from Japan, obviously close by, but all the way over to Chile. It really gives you a sense of the scale of worry, before we even knew what the waves would actually do.
That sheer potential must have been terrifying. Okay, so let's zero in on that initial moment. What was the trigger? What happened geologically?
Well, like you said, the trigger was that monster quake, magnitude 8.8, originating just off the Kamchatka coast.
Okay.
And the moment that happened, warnings went out. Tsunami warnings for just a huge list of places.
Like who?
We're talking Japan, Alaska, Hawaii, California, French Polynesia, Chile, Ecuador, Peru. Basically, a huge chunk of the Pacific Rim. Everyone was suddenly on alert.
Right, bracing for impact. So with all those warnings flying around, the big question then becomes what actually did happen when the waves hit land? Let's track that impact region by region.
Okay, yeah. And the impact, it really varied quite a bit, which is interesting in itself.
How so?
Well, in Russia, right near the source, Severokurilsk on Paramushir Island. That was the hardest hit locally. We're talking waves pushing 3 to 5 meters, so that's what, 10 to 16 feet.
Wow, that's significant height.
Yeah, definitely. That kind of water causes real problems, slammed into harbors, caused significant damage there, and forced about 2,000 people to evacuate right away.
Okay, so serious local impact. What about further afield, like Japan?
So Japan saw waves arrive in succession, building up to about 1.3 meters, maybe 4.2 feet along their east coast.
Still notable.
Oh, absolutely. And the response there was massive. Evacuation orders went out for nearly 2 million people.
2 million.
Yeah, it's a staggering number, but it really speaks to their history and their preparedness systems for tsunamis. They don't take chances.
Clearly not. Okay, 2 million evacuated in Japan. What about Hawaii? Often a big focal point in Pacific tsunamis.
Right. In Hawaii, they recorded waves up to about 1.7 meters. That's roughly 5.5 feet. Places like Midway Atoll saw that, and some island harbors, too.
And that triggers?
Widespread coastal evacuations, yeah. Again, standard procedure when waves of that size are confirmed or expected.
Okay. And the U.S. West Coast, California.
Generally, much smaller waves there, like maybe half a meter, a foot and a half, something like that in most places.
So relatively minor?
Mostly, yes. But, and this is where it gets kind of surprising, there's Crescent City.
Ah, I remember reading about that. What happened there?
So Crescent City, California. The waves were reported around 4 feet, so not huge compared to Kamchatka or even parts of Hawaii.
Right.
But the damage in the harbor, nearly $1 million.
Wait, 4-foot waves caused almost $1 million in damage. How does that work? That seems off.
It does seem counterintuitive, doesn't it?
Yeah.
But it's a classic example of local conditions really mattering.
Okay.
Crescent City's harbor, the shape of it, the bathymetry, maybe combined with how it's recovered or been structured since previous tsunamis, it just makes it incredibly vulnerable to wave amplification and surge effects.
So even smaller waves can get focused or churned up.
Exactly. They can slosh around in there, create strong currents, and cause way more damage than you'd expect just looking at the offshore wave height. It really shows, you can't just rely on the big numbers. Local details are critical.
That's a really important point. So, okay, we've got this massive 8.8 quake alert spanning the entire Pacific. But it sounds like outside of the immediate Kamchatka area and specific spots like Crescent City, we didn't see the absolutely catastrophic, widespread devastation one might fear from such a huge event. Is that fair to say?
That is largely fair to say, yeah.
So why? Why wasn't it worse across the board? What explains this kind of disconnect between the quake's magnitude and the overall tsunami impact.
Right, and this gets into the really crucial geological context. There are a couple of key things. First, tsunamis naturally lose energy as they travel across vast distances. Water just dissipates energy over thousands of miles.
Okay, that makes sense. Distance decay.
Distance decay, exactly. But maybe more importantly for this event were the specific mechanics of the earthquake itself.
How so?
The way the fault ruptured, the direction of the slip, the orientation. These specific geological factors for this particular quake actually meant it was less efficient at generating really large, widely amplified tsunami waves across the entire Pacific Basin.
So it wasn't just how big the quake was, but how it happened, the specifics of the rupture.
Precisely. It didn't give the water the same kind of push in all directions that maybe another quake of the same magnitude might have.
Interesting.
And that nuance really helps explain why, despite the valid initial concerns and widespread alerts, the overall destruction was limited. And thankfully, reported injuries were very few, mostly related to the evacuation process itself, not the waves hitting.
That's actually quite reassuring in a way, that the worst-case scenario isn't always inevitable, even with huge quakes. But wait, looking back at the sources, there's another layer here. The story didn't quite end with the tsunami waves receding, did it? Something else started happening back on Kamchatka.
Ah, yes. This is where it gets even more interconnected, maybe.
What happened?
So very shortly after this massive earthquake, there was significant volcanic unrest right there on the Kamchatka Peninsula, which is, already a very volcanically active place.
Okay, like what kind of unrest?
Well, most notably, Krasheninnikov Volcano erupted. And this was its first eruption in something like 600 years.
600 years, wow. Triggered by the quake.
It seems incredibly likely, yes. It sent ash plumes shooting up around 6 kilometers, maybe 20,000 feet. Some reports even suggested peaks closer to 8.5 kilometers.
That's a major eruption after centuries of silence. Was it just Krasheninnikov?
No, nearby Krasheninnikov, which is much more regularly active, also erupted around the same time.
Yeah.
And another volcano, Mutnovsky, started showing definite signs of increased activity, potential precursors to an eruption.
So we have this huge earthquake, a Pacific-wide tsunami, and then boom, volcanoes start erupting in the same area. This can't be coincidence, can it?
It's highly unlikely to be just coincidence. Scientists are pretty confident there's a direct link.
How? How does an earthquake set off a volcano?
Well, think about the immense energy released by an 8.8 quake. That seismic shaking, the intense vibrations traveling through the crust.
Right.
In a tectonically active region like Kamchatka, where you have magma chambers sitting beneath the surface, that shaking can essentially jolt the system.
Like shaking a soda bottle.
Sort of, yeah. It can destabilize the magma chamber, potentially fracture the rock around it, creating new pathways for magma to rise, or just sort of unclogging existing pathways.
Yeah.
It basically disturbs the plumbing system enough to trigger an eruption that might have been brewing, or even one that wasn't imminent.
So the earthquake acts like a catalyst for the volcanic activity.
Exactly. It's a really powerful and kind of humbling reminder of how interconnected Earth's systems are. An event in one sphere, the seismic sphere, can directly trigger a major event in another, the volcanic sphere.
That is genuinely fascinating. Okay, so let's try and wrap this deep dive up. If we pull together the key insights from all this, what are the main takeaways for someone listening?
Okay, I think there are three main things to take away. First, the Kamchatka earthquake on July 29th, 2025 was, the latest really big tsunami-generating event. It caused widespread alerts.
Right.
But crucially, the actual physical impact across most of the Pacific was surprisingly limited. And that was largely down to those specific geological factors of the quake itself and wave decay over distance.
Okay, point one, big quake, big alerts, limited widespread impact.
Point two, the danger was definitely real but localized. The highest risk was right there around Kamchatka. Then Japan and Hawaii saw notable waves and took significant precautions. And the U.S. West Coast saw mostly minor effects, except for that interesting case of Crescent City highlighting local vulnerability.
Got it. Risk was real but tiered, and local conditions mattered hugely.
And the third point, maybe the most thought-provoking, is the connection to the volcanoes.
Yeah.
The earthquake apparently triggering eruptions at Krasheninnikov and Krasheninnikov is just this stark reminder that geological events aren't always isolated. Earth systems are deeply intertwined.
Earthquakes can wake up volcanoes.
Pretty much, yeah.
Yeah.
Especially in tectonically primed areas.
Okay, that interconnectedness really leaves us with something to think about, doesn't it? It kind of leads to a final question for you, the listener. Given these, maybe surprising links we saw here between a quake and volcanic eruptions, what other connections might be out there? What other seemingly separate geological things, or maybe even environmental phenomena, might actually be more deeply intertwined than we usually think?
Yeah, that's a great question.
And what could understanding those hidden connections, those deep links, mean for how we prepare for the future? Not just for like a single earthquake or single eruption, but for these complex cascading reactions that our planet seems capable of, something to mull over.